Alright, we're going to talk about net ionic equations and the solubility rules. These are the rules. Pause me and write them down. You really need to write them down. It kind of helps you remember them, and so that you can use them to predict whether or not reactions will occur. This is how I knew which elements in the names and formulas of ionic compounds. I knew which elements were going to be bonding with stuff and everything else. So the easiest thing to learn on, you will be provided the solubility rules when you're using them on tests and everything else. So as first-year students, you don't have to have them memorized, but it does kind of help you to be familiar with them. If you learn what all your solubles are, nitrate, chlorates, acetates, regardless of what it's bonding with, they are always soluble, meaning you will never have a reaction if that's one of your products. Same with your alkaline metals and ammonium, always soluble. Then you have some exceptions. Lead, silver, mercury, and mercury 1 and mercury 2 are soluble unless they're with chlorine, bromine, and iodine. So regardless of who they're with, they're always soluble with those things. Sulfates are always soluble except for lead, mercury. You see silver down here, barium, calcium. Carbonates, phosphates, borates, sulfites, chromates, and arsenates are always soluble unless they're with the things, always insoluble unless they're the things that are always soluble. So as soon as you see an alkaline metal, it's not going to happen. And continuing through. And it's just a matter of using them as you go along. So when we're talking about ionic equations, what you do is you look at your balanced chemical equation. So we take aqueous sodium hydroxide and mix it with aqueous copper chloride. That's like taking a little pipette of sodium hydroxide and putting it on the reaction surface of copper chloride. What's going to happen, because this is a double displacement reaction, you've got your copper coming together and you've got your chlorine coming together. Sodium chloride is always soluble because this is aqueous because sodium is always soluble. And you're going to have copper hydroxide forming. Well, when you're writing your complete ionic equation, that's where you include everything that's part of the equation, but you break up all your aqueous stuff. So you have your sodium ions, your hydroxide ions, your copper ions, your chloride ions, then you're ending up with your sodium ions, your chlorine ions, and then copper hydroxide is solid. So it stays together. And down the bottom, well, let me go with my analogy. This is kind of coming off of the one puzzle that had you looking at the types of reactions. So you have, in sodium hydroxide's a couple, copper chloride's a couple. Well, if you think about this at the beginning of school year, you have two couples, and then they end up doing what? They break apart. So down here, they're broken apart. Well, they go to another party, and weeks, months later, you end up with two new couples. Well, after a while, one of those couples, they didn't stay together, but one really did stay together because they're having a solid relationship. So when we really come down to the bottom line, that's all net ionic equations are, is the bottom line. What reacted to cause the product that you're seeing? So you have, in this reaction, if we cross out, you see the two sodium ions are identical on both sides. Like a math problem, you can cancel like terms. Your chlorines are identical on both sides. So the only thing that are left is your two hydroxides plus your copper to make your copper 2 hydroxide. And that is your net ionic equation. So when you're trying to get to net ionic equations quickly, if you look at your products and figure out what the solid, liquid, or gas is, and then look at what ions made that up, and that will help you to write, to go from a balance equation to your net ionic equation quickly. So let's do a practice problem. Or not. Come on. You know it's always the computer, not me. Okay, we're going to write a balanced chemical equation, an ionic equation, a complete ionic, a net ionic equation for the following reaction. We have aqueous solutions of sodium carbonate. So we have sodium carbonate reacting with manganese 5 chloride. So MnCl5. That's a 5. And that's aqueous also. And it is making manganese 5 carbonate, which is Mn2CO3 5, and you can't forget what was left over, what was used before, or what's not there. Sodium chloride is your other product, and that's aqueous. Sorry, that's a 5 there, and then it's a solid on that. So we're going to balance real quick. We see that manganese, we have 2 manganese on the product side and only 1 on the reactant side, so we're going to put a 2 here. We have 10 chlorines, so we're going to put a 10 here. We have 10 sodiums, or you can look at it this way, you've got 5 carbonates. Either way, you're going to end up with a 5 over here. So we now have our balanced chemical equation. For our complete ionic equation, sorry, I'm trying to get my mouse to work. We have 10 sodium ions, 5 carbonate ions, 2 manganese ions, 10 chloride ions, going to our solid that was formed, which is Mn2CO3 5, and our 10 sodiums, and our 10 chlorides. So to make our net ionic equation, I'm going to change pen colors real quick. The things are the same on both sides. The sodiums are the same. The chlorines are the same. And when I say the same, they're written identical. Yes, you have 2 manganese on the product side over here, but it is not written as an ion. And so then for your net ionic equation, you write your 5 carbonates plus your 2 manganese gives you a product, Mn2CO3 5. So your net ionic is bottom line, what really happened. We don't care about all that extra stuff. Make sure you're asking questions. See you in class.